In this video, we are going to find certain characteristics of a relation um, just by looking at the graph of that relation. All right, so first let's start with the domain and range. Remember, the domain of a function is the set of all x values that are in uh, that are part of the relation, and the range is a set of all y values that are part of that relation. Let's start with the x values. Notice that there is no point that is on the graph of this, I would say, sideways parabola that has an x value of 6. Right? Here's all the points that have an x value of 6. That would be on that line. Notice that none of those points on that line lie on this parabola on the right. So negative 6 is not in the domain, for example, of this relation. In fact, neither is negative 2, right? None of the points that have negative 2 as the x value, such as negative 2 comma 2, or negative 2, negative 3, none of those points are going to lie on this graph. And in fact, hopefully it's fairly obvious, if I start on the left and the right, if I look at all the x values, it's not until we get to here that we finally meet, that we actually hit our first point that is on this graph. And so the smallest x value occurs at this point, and that point would be 1 comma 0. Maybe I'll put that a little closer. Now once we hit that, then for every x value bigger than 1, there's a point on the graph that has that number as its x value. For example, if x equals 3, we actually have 2 points that are on the graph. If x equals 7, again, we have 2 points on that graph. And in fact, even this graph keeps going, even though there's no arrows, there probably should be. It'll just keep going all the way up to infinity. So we say, in this case, that the domain of our graph is all the numbers greater than or equal to 1. Expressing this in interval notation, we say 1 comma infinity. And notice we use a square bracket because we want to include 1 in our domain, because 1 is an x value that exists in this graph. The range is a little bit different. A common error based on this graph, it kind of looks like the y values might be just these numbers in between here and here, looking at the graph. So maybe you might say, oh, maybe it's in between negative 1.75 and positive 1.75. But you have to be careful because this graph is going to keep going. And as it keeps going, it goes up and up and up, little by little. But if you kept extending it, eventually it's going to get all the way up to 3, right? It'll eventually reach there. If you go out to x equals 1 million, it might be as high as hundreds of thousands. The y value might be as high as in the hundreds of thousands, or as low as in the negative hundreds of thousands. So when we have an arrow like this, and the graph is not asymptotic, we can assume that even though it goes fairly slowly, the y values continue to increase and increase as the x values get larger and larger, and the y values on the bottom part continue to decrease. And so we're going to say that our range here is really all the way from negative infinity to positive infinity. And notice that every other point in between, such as 0 and 1, and eventually 2 would probably be somewhere out here. We'd hit 2. And everything in between 0 and 1 and 1 and 2, all of those numbers are hit. There are y values that exist in the range of this function. Next, let's find any intercepts. When we have the graph, this is fairly simple. We're just going to look, does the graph cross the x-axis or the y-axis or both? Notice that it actually does not cross the y-axis, so there is no y-intercept. It doesn't get to the y-axis. However, it does cross the x-intercept, and I'm going to erase some of these marks I've made, and it crosses the x-axis right here, and again, this point is 1, 0. Finally, is there any symmetry here? And it does look like there is symmetry. In particular, it looks like there is symmetry over the x-axis. If I trace this x-axis, you can see that that acts like a mirror line, right? And so this point here is reflected to this point over the x-axis. Or this point right here gets reflected to that point over the x-axis. And so we would say that, is there any symmetry? This graph is symmetric over the x-axis. All right, and so that's our first example. Let's do a similar example. I'm going to copy and paste this. All right. So again, let's start with our domain and range. Now again, you have to be careful here. It does kind of look like my domain, again, that's all the x values. It seems like maybe it's only between these two numbers right here. So maybe if I would say the number one error a student might make is that you would say the domain is in between -3 and maybe +4 or something like that. But remember, this graph keeps going to infinity. And my x values, as the graph keeps going, it's going to get smaller and smaller x values. And as it keeps going in this direction, it'll get to bigger and bigger x values. Okay? And so the way I think about it, if there's an arrow going off kind of to the upper left or to the lower right, you can assume that these values will continue going in the negative x direction and the positive y direction, according to this arrow. And according to this arrow, it's going to keep going to the positive x direction and to the negative y direction. For that reason, the domain is actually going to be, again, the x values will keep going to all the way to the left and all the way to the right. And there are no holes in the part of the graph that you can see. So we're going to say it goes from infinity to negative infinity to positive infinity. That is our domain. It'll have all the x values, all the real numbers. And similarly, for the range, you can tell that it's going to keep going up to infinity. It's going to keep going down to infinity. And it has all of the values in between. In this case, what we can see is from +12 down to -9. So the domain and range is going to be all real numbers in this case. and expresses in interval notation, that'll be from negative infinity to infinity. Are there any intercepts? I would say yes. Here we have, I guess we'll start with the x-intercepts. We actually have multiple x-intercepts because our graph crosses at 3 points. It crosses the x-axis. That would be at negative 2, 0. This would be at 0, 0, and at 3, 0. And so we'll list all of those. Now, does it cross the y-axis? It does cross the y-axis, and it actually crosses it at a point where it also crosses the x-axis at the same time. Right there. So here is my y-axis, and notice my graph crosses at 0, 0. So the y-intercept, there's only one. Would be 0, 0. So notice if your graph ever crosses the origin, then 0, 0 will be both the x-intercept and a y-intercept of your graph. All right, let's think about symmetry. Now, it does not look like this has any, it doesn't look like a mirror image anywhere, right? If I flip this over the x-axis, it wouldn't look the exact same. If I flip this graph over the y-axis, it wouldn't look exactly the same. But it does look like if I rotated it 180, it might look about the same. And I'm just going to show you that over here in Google Slides, where I can rotate this. So I'm going to rotate this 180, and I want you to notice that it looks almost the same. So when I rotate it upside down, it still kind of looks like an S, right? You can kind of see that that's, oops, I messed that up. Let me try that again. It does look like the same basic shape. So you might think that maybe this has symmetry about the origin, but you have to be a little bit careful. The rule, if it does have symmetry about the origin, then the rule would be that for every point that is on the graph, the opposite point is also on there. So opposite x and opposite y would also be on there. So for example, I know that negative 2, 0 is on my graph. It's right here. If this graph has symmetry about the origin, that would mean that the opposite point would be on there, which would mean opposite of negative 2 is positive 2, and the opposite of positive 0 is negative 0, but negative 0 is the same as positive 0. So 2, 0 should be on this graph, but 2, 0 is right here. It is not on that graph. If that is case for even 1 point, we know this is not, there is no symmetry about the origin. And you can kind of tell, if you really look at it, this hump right here is smaller than this hump right there. So if I rotated them 180, then that purple part would end up looking more like this, and the green part, after rotating it, would look smaller like that if I did rotate that around. So it's not a reflection over the x-axis, it's not a reflection over the y-axis, and it's also not symmetric about the origin. There is no symmetry. And so sometimes you have to be careful, and sometimes it's smart to double check your work using the rules that we learned for different types of symmetry. All right, well, that concludes this video. Hope that was helpful, and we will see you in the next video.